Hi, I'm Kitsap County Commissioner Rob Gelder, and welcome to this episode of Commissioner's Corner, and welcome also to the Central Kitsap Wastewater Treatment Facility, where you'll learn all about what happens when you flush your toilet. So joining me now is Dennis Graham, who is the maintenance supervisor for the sewer utility. And so what does that mean?
So I'm in charge of the facility maintenance crew, the electricians, and our mechanics, and we basically service all our pump stations and any equipment associated with that.
Okay, great. So today we are at what we affectionately known as Pump Station 67.
Correct. And Pump Station 67 collects all the collection system sewage from City of Paulsbo, Keyport Base, and proper Keyport. We have a small collection system in Keyport, and approximately 800 million gallons a day runs through this pump station.
Wow, so the Keyport is here and Paulsbo is across the water. How does that get to here?
It is, so their collection system has two siphons that go underneath the water, the channel here in Paulsbo, and it basically gravities all to this pump station. So their pump stations in Paulsbo, all their collection system flows through the two siphons in Lamolo and then ends up at this pump station.
Okay, and we are next to a sign that says Central Park, which is kind of interesting. You wouldn't necessarily think of a pump station in a park, or maybe it's a park around a pump station.
A little bit of both.
Yeah.
So this particular pump station, we do have odor control devices, for smells and things like that. We are in the process to add water and power to the park so they can use it, have different concerts and things like that through the year.
Yeah, I know it's been a great collaboration with Public Works and the local Keyport Improvement Club to really make this because it's pretty centrally located.
It is,
right in the middle of the heart of Keyport.
Correct.
Exactly. Well, why don't we go ahead and check out what this pump station does?
Sounds good.
Okay, great.
Let's
Thanks.
go.
So Dennis, what is the purpose of a pump station?
So the pump station basically is a low point in your collection system, and it collects all the water in a wet well, and then it pumps it to either another pump station, but the ultimate goal is to get it to the treatment plant.
Okay, so this wet well it basically takes everything from the Keyport Base, the Keyport proper in Paulsbo.
Correct.
And then it lifts it and sends it on its way to be treated at the CK treatment plant.
It does.
The tricky thing is, though, that doesn't seem like a 9-to-5 kind of job. This has got to be able to operate all the time.
It does. It's a 24-hour process. We have redundancy at these pump stations, so if we lose power, we have backup generators. This particular pump station has 3 pumps, so if a pump happens to go down or anytime we have to do maintenance, we're able to still run the pump station. Also, this pump station communicates with our SCADA system at the treatment plant, so any alarms that come in throughout the night would send an alarm to an on-call personnel, and then they would come and take care of the issue during that time.
So you said SCADA system, but that's just sort of the control?
It's a data control computer program that collects the signal from this pump station and tells us what's going on at the pump station when there's nobody here looking at it.
Okay, so what happens in the wet well? What value does that offer to sort of the process to make sure it's working well?
Yeah, so the wet well basically is a place where the sewage comes to, and then you don't want pumps to run all the time or turn on and off as much, so it's engineered to have a holding time, and then the level control system tells the pumps to turn on and off, and then they run at that particular time.
So then how do you clean it? There's got to be a maintenance process for the pump station and the wet well.
There's a couple ways you can clean them. This particular pump station have what we call a flushing system.
Okay.
And the pump stations collect a lot of floatable fats, oils, and greases. They float to the top, and they can interfere with your transmitters and your floats, and they can send alarms. And then you have to come out and take care of that. So this particular station has this flushing system to clean it, and then when some of it does start sticking to walls and piping, so then a Vector truck would have to come and then clean the rest of that up.
Okay.
So it definitely helps with the process of cleaning the fats, oils, and greases.
Okay, great. So How does it get turned on? Does it go on automatically or?
No, so facility crews come out, there's a few valves they have to open and close and turn a few pumps on and off to make that process happen.
Okay. Can you show me how to do that?
I can.
Okay, perfect.
Let's go.
Yeah.
So we'll be turning on pump 3 and 2 in
Okay.
hand or in manual. So there's your switch there, you turn that
Okay.
and then you hit the start button.
Start button. And this is to basically help flush the wet well?
Correct.
Okay.
Yep, so it'll pump it down and then the other pump will run the flushing system itself.
Okay. Here it goes.
And then we'll do the same thing on 2.
Okay. Okay.
So now we can go to the wet well and see what's going on.
Perfect. Thanks.
And that's how it's done.
So Dennis, shall we go to the Central Kitsap Treatment Plant and see the rest of the process?
Yep.
Great.
Sounds good. You're welcome.
Joining me now is Matt Pickering, who's the lab supervisor at the Central Kitsap Wastewater Treatment Plant. And Matt, can you tell our viewers a little bit about where are we right now in the process of treatment?
So currently we're at the aeration basins. These basins are intended to promote organisms and a balance of organisms to reduce pollutants before discharge into Puget Sound.
So you say organisms, this is then really a biological process you're talking about?
Almost entirely. Everything you see mechanical is intended to distribute the organisms to different parts of the process to treat and reduce specific pollutants. So we have aerobes, we have nitrifiers. So we're trying to reduce things like solids, biochemical oxygen demand, and also nitrogen. These basins promote organisms that reduce ammonia nitrogen to nitrogen gas so that the nitrogen is released to the atmosphere as nitrogen gas as opposed to the Puget Sound as a pollutant.
So ultimately, our goal in treatment is what?
Our goal is minimal impact on Puget Sound.
Okay. So, and we have a permit from the federal government Department of Ecology that says that's how we can operate this facility to treat all of this. So,
Correct.
Are there certain chemicals then, like you talked about, that are those target chemicals we're keeping track of?
We keep track on a regular basis of what's called biochemical oxygen demand. It's an overall measure of pollutants that are still in the effluent leaving the treatment plant. We measure solids, and then we're required to measure nutrients fairly regularly. So nitrate nitrogen, ammonia nitrogen, total phosphorus, and soluble reactive phosphorus.
Wow,
So
that's a lot.
it is a lot.
And so hence we need to have a lab to sort of take samples and make sure that we're meeting our targets.
Correct. And in the laboratory daily, we're also giving feedback to the operators on a regular basis. So our laboratory is very routine in giving feedback to the operators to know where their organisms are in the process, how much of the organisms are there, and what pollutants are in what stage of either reduction or treatment.
So the organisms that are really doing the heavy lifting in this treatment cleaning process, where do they come from? How do we introduce them into the process and keep them going?
So they actually come from us. So they are a steady feed into the treatment process. The reason that the water in the aeration basins now looks dirtier per se is because we try to retain as many as we can through what we call mean cell residence time. So these organisms go through the loop and go through the process for maybe 3 or 4 days. As we promote certain organisms to reduce nitrogen, it might be 7 or 8 days that those organisms stay in the process because it takes that long to do the chemical reduction to nitrogen gas.
So can you tell us a little bit, in some of the basins we see air being added to them, others are still, and so what's happening there?
So what's happening there is there's certain organisms that are aerobes. They like to be in an oxygen-rich environment. So as they go through the process, they'll go through a zone that doesn't have a lot of air, so they're relaxed, they might be a little stressed out, but as they get into the aerated zone, they focus on those pollutants that they consume and then reduce from the water. Then it's vice versa. So the organisms that like an anoxic or low oxygen environment will be stressed out under air, but they'll focus on the pollutant that is their uptake and their chemical change in that zone. So it's a steady feed of active, rest, active, rest.
So you don't want to tire the organisms out too much,
right?
Or
And
stress them.
And it's a very difficult balance for the operators because each organism is dependent on a certain level of oxygen, a certain temperature, and a certain chemical to be present to do their job.
So how do you keep track of those to make sure they're getting what they need and monitoring them?
So we have multiple ways. We have inline probes that'll give feedback immediately to operators for levels of dissolved oxygen, also for ammonia and nitrate nitrogen. And then we do laboratory work, so the solids analysis, and when I say solids, I'm speaking of the actual organisms themselves. We can measure quantity, and we do that test every day and let the operator know how many organisms are in what part of the process.
So you're constantly testing to make sure that the system is kind of finely tuned.
Yeah, our requirements are daily, weekly, monthly, and yearly, so we repeat that cycle over and over.
And where do the reports go to after they?
So the reports go to the Department of Ecology for this facility. Kitsap County has 3 facilities that reports to the Department of Ecology, which is the state. And then we have 1 facility that's on tribal property where we report to the Environmental Protection Agency.
Okay. So what would you say are generally the capacity of this facility?
So capacity for flow is about 7 million gallons. Right now we're operating at just over 3 million gallons a day.
Okay, so there's reserve capacity, one would say.
Correct.
Do you ever have to then, because this facility is being used right now, these basins, do we have the capacity to sort of move around for maintenance purposes?
Certainly, yeah. Right now we actually only have 2 of 4 basins online for aeration right now, so we can transfer to basins 1 and 2. And we will be putting on a 3rd basin over the summer because to increase that mean cell residence time from 3 days to 8 days, we need additional capacity. And the purpose of that is to treat the nitrogen.
Okay, so we've got capacity, flexibility to make sure that we're meeting our targets and making sure that the organisms that are doing the work have what they need.
Currently, yes.
Great. So behind us, I know there are some probes in the basin. So what are they doing? What are they measuring?
So those probes are specific feedback directly to the operator. So there's a meter connected to the probe. The meter is hooked up to what we call a SCADA system, where the operator can be in his office and get steady feedback, immediate feedback on what levels those probes are indicating. The organisms are very dependent on oxygen, so we need to give that feedback immediately to make sure they have enough oxygen available in their step of the process.
So we're measuring dissolved oxygen and
nitrogen.
And
so we're
nitrogen.
measuring ammonium nitrogen and nitrate nitrogen to test the conversion of the toxic ammonia to a safe nitrate nitrogen and eventually to nitrogen gas.
Okay. Can we check out the monitor over there and see what
absolutely.
it's showing us?
Yeah.
Okay. Oh, I see. So it does an immediate readout here for the potassium, the chloride, the temperature. Oh, lots of.
Yeah, so this meter is also designed for ammonium nitrogen, nitrate nitrogen. Potassium and chloride are present and they're interferences with the other ions. So we measure them to compensate for that interference electrochemically.
Okay, so information's coming here. It's also going into sort of the operations center to manage everything. What do staff do to kind of respond to the measurements that are being taken?
So the key thing for this meter is really the oxygen level for the organisms. So if there's a concern, if the oxygen is low in the aerated zones, they can actually increase the blower speed on the blowers that provide the air to this basin. It's a large blower system. All the ducting that you see is all air being pressed to the bottom of the basins and forced up through the liquid stratus and to be available for those organisms. The nitrate and ammonia levels are just more for monitoring. There's really not process control they can do. They would have to change the air on or off in a particular zone, not the particular level.
So there's they look like they're like floating tops, but those are basically large fans of sorts?
Yeah, so it's a mixer on the top, but most of the aeration is taking place by a series of diffusers on the bottom of the basin.
Okay.
So the diffuser is evenly distributing air bubbles up through the
liquid.
it's called activated sludge.
Okay, very cool.
And then what you see on the top of the basin is an indicator of other organisms as well. We have some organisms that'll float on the top, some that'll stay in solution, and even the color can be an indication as the type of organisms we have in the basin.
Okay. Does it, so the color also visually could give an indicator of sort of what's going on, sort of how happy the system is and the organisms?
Especially in the foam organisms on the top. Ideally, this is a good amount. We don't want a lot more than that.
Okay.
But that can be an indicator as well.
And so what are the hoses that are spraying on top of the basins doing?
So each basin has 6 zones, and it just goes through these series of steps that have to make 90-degree turns. So these hoses allow us to kind of force off the top some of the dead zone areas at the corners.
Okay, very cool. Well, I know that one of the things we need to do is make sure that we're meeting our targets. Should we take a sample?
Absolutely.
Okay, awesome, let's do it. Here, I'll hold
So
this.
if you want to hold
Yeah,
that?
grab the bottle. So obviously you don't need the whole, you don't need to be full, right?
I do not need to be full.
You just plunge a few times?
Yep. The goal is just a representative sample.
Okay.
You know, we have hundreds of thousands of gallons in the basin, but we're trying to represent that basin based on just, 500 milliliters of sample.
Uh-huh.
So we can measure this sample physically for solids, chemically for nitrogen components, and
Is that enough?
biologically for the bugs. And that'd be enough, yes.
Okay.
So this would then get transferred into the laboratory for analysis.
Do you have to clean this off or anything?
No, we can just set it right there. We clean them weekly.
Okay. Great. Well, let's keep on going and check out the other processes and get to the lab and check it out.
Okay.
Okay, awesome, thanks. So Matt, where are we now?
So we're at the secondary clarifiers. So after aeration in the basins, the organisms are brought into the clarifier where air is removed and food is removed. So they go into kind of a rest mode, and as they do that, they settle together in what we call flock. That sludge settles, and some of it's returned back to the basins for more treatment. Those organisms are viable, and they'll treat more pollutants. The clear water that comes out the top goes over weirs and leaves the secondary clarifiers for UV disinfection.
So did we miss any steps along the way from the aeration basins to here?
Just the channel that the activated sludge is flowing in.
So, I mean, it's remarkable just the change. You talk about the sort of, I mean, from the visual in the aeration basin to the water that's going over the weirs, it's remarkable the difference that's taking place.
Yeah, and surprisingly, as we see the water look dark here, that's actually an indicator to the operators that the water's cleaner. So we want to see it dark. It's actually not the water that's dark, it's that we can see the depth and the shadows.
Of the actual...
Of the actual water. Yeah.
Oh, cool.
Yeah.
Well, why don't we go check out the UV station then? Okay, perfect. So Matt, we have seen this whole process of going finally to the secondary clarifier, but we're now at the spot where what happens here before we actually discharge the water?
So we're at the UV disinfection system. This is a recent upgrade completed by Kitsap County to improve electrical efficiency. It's about 90% more efficient than the old system.
Wow.
But as the solids and organisms go through secondary clarification, we don't remove 100% of those organisms. So there's still pathogens and fecal coliform in that water. So we pass them slowly through a series of UV lights to disinfect, kill, and sterilize that water prior to either from here discharge into Puget Sound or discharge through pumps to our sand filter for tertiary treatment.
So with the tertiary treatment, that's an investment the county's made to get us to ultimately be able to recycle water.
Yes, we would love to recycle that water, and just with a turn of the switch, we're basically capable of creating that water, but we need to be able to store it, treat it one more time, and distribute it to Silverdale Water District for use in the community for non-potable uses.
Okay, great. So I think we've talked a lot about the treatment of the water side of this process, but there's also the solid piece of it. So why don't we go check that out?
Sounds good.
Okay, thanks. So Matt, where are we now?
But right now we're at the facility's cogeneration system.
Okay, great. And what is that? What does cogeneration mean?
Cogeneration means that we're able to produce power and heat through the use of methane gas capture and conditioning. So as the solids are removed from the water treatment process, the solids go through other stages of treatment to stabilize those solids.
Okay.
The solids are stabilized in basically an industrial stomach or a digester. So it's high temperature, it's meant to reduce pathogens and also reduce odorous components of the solids. A byproduct of that stabilization process is methane gas.
Okay.
We can capture that methane gas, send it through this conditioning system to remove hydrogen sulfide, to remove water, and then burn it in an engine that creates electricity. That electricity can provide up to 250 kilowatt hours, which,
Wow.
which will operate half of the facility under that power.
So the product that's being treated here is creating energy that goes back into fueling the plant and also helping, I think, to reduce our diesel requirements for the digesters in that heating process?
Absolutely. The digesters run at a very high temperature, actually our body temperature, about 36 degrees Celsius. So we can create heat through the system, return it to the digesters, and reduce the dependency on diesel fuel to heat the digesters.
I would have to say, in terms of the improvements that have taken place over the past few years here at the Central Kitsap Wastewater Treatment Plant, this is one that I find really exciting, just being able to kind of close the loop and be able to take something that otherwise would be flared off and make it work again for us.
Certainly.
That's awesome. Thank you very much.
You're welcome.
So Dennis, we've talked about the digesters and stuff like that and how the solids are processed, but can you tell us a little bit about one of our final steps being the centrifuges?
Yeah, so this is our process building where our centrifuges are housed. We're in a capital improvement project right now, which we have 2 new centrifuges that we're actually starting up today. It'll be about a 30-day process for it to go through the startup, and we accept the project. So they're centrifuge units, and they basically produce about a 25% cake, which is a biosolid.
Okay.
And then it gets dumped into a truck, and then we haul it to Eastern Washington, which they use the biosolids as fertilizers.
So we're basically the centrifuge pulling as much of the remaining liquid out.
Correct. Yep.
Okay.
So basically, it's got an outside scroll or an inside scroll and then a bowl on the outside. So it spins at about 3,000 RPMs, and water goes one way and solid goes the other way.
That's cool.
Yep.
So we want to basically make the solids ultimately as light as possible.
Correct.
As we're trucking them over the road.
Yeah, the lighter you can make it, the more you can haul.
And then so the water that is pulled off of it then goes back into the system?
It does. It goes back into the headworks and starts in the process again from the beginning of the process.
Well, this is amazing just to know all of the various steps along the way and the huge amount of equipment and infrastructure that it requires to make sure that we're doing the best job we possibly can.
Yes.
Well, thanks a lot. I appreciate it.
You're welcome.
So this is the lab.
It is the lab, and what I'm going to show you is how we identify the microorganisms that are out where we took that sample at the aeration basins earlier.
Awesome.
This laboratory is state accredited by the Department of Ecology as well,
Okay.
and so we test 17, 18 different chemicals prior to discharge into Puget Sound.
Wow.
But I'll show you how we can identify a microorganism.
Great.
So we take that sample that we collected, shake it up good. I'm just going to put it into a secondary container. This helps me kind of see how those solids would settle in the secondary clarifier out in the field. But if you go ahead and take an eyedropper, take a little bit of it, just place it on your slide,
How much?
just 1 drop,
One drop, okay.
put it back in the beaker, and then if you want to grab a little cover slip, place that
This kind of
securely over
reminds
the
me
drop.
of my days back in my chemistry or biology classes back in school.
Oh yeah, college lab, absolutely. So I'm just going to dry off any residual water off of your slide,
Okay.
and then we can transfer that to the microscope.
Okay. So that to go under the clips?
Yep, go right in between the 2 clips. And then the adjustment to get you located, you can go front and back, side to side.
Yeah,
We'll
like
find
this.
that location and your image will come up on the screen over here. So you can either look through the eyepiece of the microscope or we can look onto the screen. So now you'll be able to see those organisms. And you see what we call the flock. Those are the lighter colors that you see in there. Looks like snowflakes. Coming out of the flock, you have like a spaghetti-like organism called a filamentous bacteria. So the filaments are the foam that are floating on the top and some of the other organisms that, that grow in activated sludge. So we have free swimmers. That's an indication that life is good in the activated sludge. We have ciliates that are making their way around and mobile in the solution. And then we have things like stocked ciliates and other filamentous bacteria. So I can show you, if you'd like, what the operator would look for.
That's pretty amazing. So you can either use your eyes or it pops up on the screen.
Certainly.
Okay.
So there's one free swimmer, just right there. And these little spaghetti-looking organisms are not necessarily bad. An excess of them, if you get too much in there, that settling that occurs in the secondary clarifier would be inhibited because all that spaghetti material is taking up the free space between the other organisms.
Great. So not only this sample is specifically from the aeration basins, but you're taking samples from basically every step along the way.
Yeah, we monitor the plant at the influent, at our headworks, and at our effluent. And then for process feedback to the operators, we're testing all the way through the process. They want to know where their organisms are, what organisms are there, and then based on the permit from a Department of Ecology, we're required to test our discharge to Puget Sound. So once we provide that feedback, the flow is going out all the time, but as we provide that feedback, we know we're discharging clean, safe water to Puget Sound or preparing water for the tertiary step for sand filtration and recycled water.
So how often every day do you have to take samples on every step of the way?
Yeah, we take samples every day for things like pH, solids, biochemical oxygen demand, nitrogen. We test some up to 3 times a week, depending on what stage of the permit that we're in. And then we test for metals, we test for fecal coliform. We want to make sure we've disinfected the water prior to its discharge into Puget Sound.
Great. So this is, I think, a really complex process that not everybody appreciates when they either take a shower, they flush a toilet, do their dishwasher or whatever, but it all comes here, and the staff of Public Works and our sewer utility are really looking at making sure that we do the very best job we possibly can to ensure the best quality of water is discharged, and someday, ultimately, we have the best quality that is able to be recycled and reused in our community.
Correct.
So great. Well, Matt, thank you so much for taking me on the tour, and I appreciate it. And we will, I know I've learned a lot, so I'm sure all of our viewers have as well.
Yeah, thanks for coming and joining us today.
Thank you. Thank you for tuning in to this episode of Commissioner's Corner. I hope that you've learned a lot. My thanks to the guests today, but also I want to call out really that this is a complex process, that whether you work in a lab and you're a scientist or you're an operator, we have electricians, mechanics, you name it. This is a complex process that takes a lot of different jobs to make it happen, to make sure that we discharge the best possible effluent out to and into our sound. So you are a big part of it, and so remember, think twice before you flush, because it has a big impact downstream. So see you next time.